Good evening. I'm Namita Joanna Victor, and my project is customer churn prediction using machine learning. So, you might ask why customer churn prediction is so important. Well, in today's world, when new businesses are opening every day and the online world isn't getting any smaller, it's increasingly important for businesses to understand how to retain their customers. The goal of this project is to be able to identify and provide a solution to these businesses so they can stop customers from leaving them. This will help businesses create strategies that specifically target these customers. It's also going to improve their customer satisfaction rate, boost their loyalty, and ultimately give them long-term success. In this project, I found out how machine learning models could predict when customers churn and why they were churning in the first place. This project went through four main steps: data pre-processing, an exploratory data analysis, model development, and a feature importance analysis. We will be going through all of these steps one by one. Now, data pre-processing. So the dataset used was a telco customer churn dataset, which is essentially a telecommunications company's customer information. So to start off, the dataset had about 7,000 rows and 21 features. So while going through this data set, I found two main issues with it. And one was that the total charges feature had the wrong data type. So I needed to convert that to a float data type so that we could process it correctly. And another issue was that total charges also had a few missing values. So I did not want to discard these samples as a whole. So instead, I used the mean of total charges to fill up those missing values. The next process was data transformation. I used two processes, label encoding and one hot encoding. So the features I used label encoding with had only binary outcomes to them, and so it made sense to use label encoding. The reason I didn't use it for the other features was because I didn't want the model to assume that a higher number meant higher significance. So instead, I used one hot encoding, which separated them and helped the model understand better. Moving on to the next step, exploratory data analysis. Now, during my exploratory data analysis, I was able to find out a lot of uh, things about the data set and understand the customers better. So I used two types of visualizations. One was a univariate graphical analysis, and the other was a bivariate graphical analysis. So to start off, we have a histogram of the distribution of customers over tenure. So tenure basically shows us how long customers have been with the company in months. And if we have a look at this distribution, uh, we see that it is bimodal. So we know that there's a large influx of new customers to the company, but there's also quite a large volume of customers who have been with the company for a long time. But because this is bimodal, there is a middle portion where there's not many customers there. So this could indicate a lot of customers that are joining in new aren't really wanting to stay for that long period of time. And maybe this could say something about the business model that this company has. The next graph is a distribution of customer monthly charges. So this shows the company exactly where their revenue is being generated. So from this distribution, we see there's a large volume of customers who are paying $80 or more. But there's also a large volume of customers who are paying $20 a month. So we understand that the two main streams of income of revenue for this company are customers who are willing to pay for premium features because they are loyal to the company, but also customers who are content with the base package of the company. The next visualization is a heat map. Now this heat map showcases the numerical features in our data set, which are tenure, monthly charges, and total charges. So the main thing I observed with this heat map was that it showed total charges was heavily influenced by how long the customer had been with the company, meaning there wasn't a lot of customers spending a lot as newer customers. So the higher total charges are mostly from just loyal customers. But also, I saw that the monthly charges had absolutely no relation with tenure. So tenure didn't play a factor in whether a customer is paying more monthly or lower monthly. The next step is model development. So to start off, we split our data set into training and testing, and the model we chose to use for this project was random forest. And the reason for that was because random forest is really good at understanding non-linear relationships, and the customer churn dataset doesn't necessarily have linear relationships between its features. And so because the random forest model had the ensemble of decision trees that it does, it made sense to use this instead. Now, after we split the test and training data, another important thing that I had to consider was that the classes were imbalanced. So if you see here, churn, the amount of positive churns were much lower than the negative outcomes for churn. And so I tried to use Smote to remove that imbalance. And Smote basically created synthetic samples for the class that did not have enough samples. And so this helped balance our data set a little more. The next step was feature importance analysis. And over here, Random Forest had a feature built into it to find out the feature importance of all the variables. And so in this graph, you see how contract, tenure, total charges, etc. These contribute a lot more to the predictions made by the random forest model. But this shows us the general overall importance each feature played in the prediction. So later on, we will see how SHAP gave us a better understanding of what features actually helped each prediction. So our results, for our results, we used we used a few different methods. The first one is a confusion matrix, and I saw that our model did pretty well, and there's a large percentage of labels that were predicted correctly. As you can see, about 15% of our labels were either predicted wrongly as not churning or wrongly as churning. Now, the next method we used was classification report. So this classification report showed us precision recall, F1 score, and accuracy with respect to the model. Now, precision showed us that 86% of customers were predicted as not churning, whereas 82% were predicted as churning, which is pretty good for our model. But A feature that I want to point out specifically was recall, um, because we had the model identified 80% of the customers who did not churn correctly, and 87% of the customers who did churn correctly. So this kind of gives us a better look into how well our model is performing, and this higher recall has lowered the risk of our model not being able to identify customers who are likely to leave. The next method we used to evaluate our model was the ROC curve. So this showed us how well our model is able to rank cases correctly according to their predicted likelihood of churning. The model had an ROC score of 0.84. So this showed us again how effective our model was able to predict our churn and no churn. And we achieved a pretty high accuracy, I would say. The next method was SHAP. So as we mentioned before, feature importance was a critical part of this project. There is no point in finding out whether a customer is going to churn if we don't know why they're churning. So SHAP gave us a more pinpoint accuracy on, hey, this is exactly what's affecting churn or what's not affecting churn. So if you look at this visualization, you see red indicates that there was a positive impact, meaning that it did increase churn risk, and blue was a negative impact, meaning it reduced churn risk. So the main features I want to take away from SHAP was that it identified month-to-month contracts had a strong impact on churn. This could probably mean that maybe customers are not liking the month-to-month contract as much, and it's causing them to leave the business. Long tenure also had a negative impact on churn. So people who had longer tenure, of course, were more loyal to the company. So we don't see people who have long tenure leaving as much. Another interesting effect I observed was that customers who had taken tech support or opted into online security had a decreased risk, and the opposite was true for like a lack thereof. So a lack of tech support or online security also increased churn risk, which was an interesting observation. So that could provide the business with a better understanding of what they could improve upon to help customers stay with them longer. Now to conclude my project, the customer churn prediction was successful in predicting whether customers would churn or not. I was also able to observe that this would greatly contribute to businesses being able to improve their business models and understand why customers were leaving them in the first place. And the SHAP analysis specifically was able to provide a better explanation on what was happening with customer churn. Anything that I would change for the future or would work on for the future would be that the accuracy of the customer churn predictions could be improved. So in the future, I would probably try using neural networks to improve accuracy. But the project was successful, and yeah, that is my project. Thank you.